Today we are going to talk about how to multiply and divide with rational expressions. So remember, rational expressions are things that have x's in the numerator and denominator. So we're going to talk about how to multiply and divide those. Before we do that, we want to kind of warm up with just remembering how to multiply and divide fractions. So when we have this first fraction, 3/8 times 2/5, we can just multiply straight across, but then we might have to reduce at the end. So remember, we are allowed to reduce things on the diagonals. This 2 and this 8 are both divisible by 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. And I can just reduce that kind of ahead of time and then multiply. 3 times 1 is 3, and 4 times 5 is 20. And then I don't have to worry about reducing at the end of the problem. So just remember that you can reduce on the diagonals like that. Now, when we go to divide fractions, we don't divide fractions. What we do is instead we multiply. We multiply by the reciprocal. So remember, this is 3 over 1, so we're going to multiply by 1/3. We can reduce on the diagonals. Those are both divisible by 3, and so our answer is going to be 3/4. So we're going to apply those same principles when we start multiplying and dividing with rational expressions. Before we do that, let's just work on simplifying. Okay, so we've already kind of done this with our graphing, but if we want to simplify this thing, we are going to start by factoring. So I'm going to start with the numerator. This is going to factor into y and y. They are going to be opposite signs. I'm looking for things that multiply to -24 and add up to -5. So 8 and 3. And then in the denominator, I want to factor at that. It just has a GCF, so I'm going to factor out a y, which leaves me with y plus 3. And then I am allowed to cancel. I can cancel on those diagonals. And so my simplified answer is y minus 8 over y. All right, let's take a look at one more of those. So again, to simplify, we're just going to start by factoring. So these are going to be same sign, both positive. I'm looking for factors of 15 that add up to 8, so plus 5 and plus 3. I'm going to factor the denominator as well. Those signs are different. I'm looking for factors of -12 that add up to -1, so -4 and positive 3. And x plus 3 will cancel, so my simplified version is x plus 5 over x minus 4. Okay. Now, one thing that we didn't talk about this is the domain. Domain, remember, that's all of the values that we're allowed to plug in. So our domain is going to be anything we want. We can plug in whatever we want for x, except we cannot plug in things that will cause us to divide by 0. So if you notice, if you look at this one, if you plug in 4, you'll be dividing by 0. So x cannot be 4, and x cannot be -3. So even though that -3 canceled out, it is still considered an excluded value. Going back to number 3, we want to do the same thing. We want to talk about the domain. So the domain of this problem is all real numbers. We can plug in whatever we want, except we cannot plug in things that will cause us to divide by 0. So we can't have 0, and we can't have -3, because both of those would require us to be dividing by 0. Okay. In the next video, I'll show you how to do products.